5 by 0.02. Yeah, 400. Because you move this over twice, move this over twice. 800 divided by 2, 400. Or you just play in the calculator. So if you like is over of, you don't want to go away from it, please do it that way. It's fine. You really, really didn't need to be taught that. Truly. Yeah. Yeah, you gotta feel that, yeah.
69 is the same. 69 is the same.
Okay, so let me get back into section 2.3, and I want to try to get a few more sections under our belt today. Word problems, I don't mind hanging out word problems for a little bit because that's obviously on the top of everybody's list of what do you like least about math, right? But I hope to God you guys kind of see the setup. If you just set it up in some way close to what I suggest, it makes it a lot easier. Right? If you just give yourself some breathing room, you don't have to know how to do the problem by reading it once. That's insane. Right? So what do I mean by that? Look at number, let's do one of these because we haven't done one. Page 127, number 23.
Is he doing that?
Yeah, that's
the same page?
What's that?
The same page.
On the same page?
Yeah.
Oh, I like this one a lot because it cracks you. So what's the first step? It's actually sort of the zeroth step here because it actually makes sense to maybe draw this out, right? It's a triangle, so I can draw a little. There's my triangle, yay.
The smallest triangle is 1/3, so the smallest is 1/3.
Now careful now,
Okay.
careful. I don't want to bring any numbers into this right now.
Okay.
Well, it's pure English, right? How many players are there? 3.
Three.
And what are they called in this problem?
Small, large.
Smallest angle,
Middle, and large,
what are the names in this problem?
Largest.
largest.
Yep, largest
Oh, and third.
and third. Now, you do not have to do it this way, but it makes it so much easier to kind of check yourself, where did this come from? If you use the same language they do, instead of saying first, second, third, there's no connection there. You forget, you're like, where did that come from? So which one has got to be X?
Smallest.
Why smallest?
Because you don't know what it is.
True, I don't know what any of them are. But what tells me which one is just X?
Because everything else is based off of that.
Beautiful. So which one, guys, which one is everything based on? The smallest is 1/3 of the largest. The third is 10 more than the smallest.
So that's the
Interesting.
first one.
Smallest.
Largest is the one I gotta start with, right? I gotta have the largest be X. And now what's the smallest then?
The smallest. Third. 1/3.
Good. Smallest is 1/3 of the largest. Now that I know the largest, I can come in, the third angle is 10 more than the,
So it's 10
smallest.
So
Careful, is
X
that-
plus 10.
It doesn't say it's 10 times the largest.
No,
It says it's 10 more than the smallest.
Plus 10.
1/3.
Yeah, 10 more than
Third
the smallest.
Yeah.
Now, let me go back over that real quick. The smallest depended on the largest, and the third depended on the smallest. So I've got to start with the largest. That's where everybody kind of starts, right? So that's got to be X. Then I know how to write the smallest one. And now I know how to write the third one because it's based on what the smallest one is. So now I've given them all math names, right? Now here's the trick. Here's the other part of this. What's the equation? What's true about any triangle?
180.
180.
Beautiful. When you add all the angles. So I'm not going to tell you that in the problem. I'm not going to tell you that in the problem. You got to remember, triangles add up to 180, all their angles,
Yeah.
right? So I got this angle, the smallest angle, plus the largest angle, plus the third angle is 180. And I can find all my angles, right? There's the smallest, there's the largest, there's the third. What people do a lot of times is they'll forget the 1/3 x. They're like, I already got a 1/3 x in there. Well, you need 2 of them. You got to be able to find each angle, right? So now you just attack this bad boy. If you want to, you could kill the fractions right off the bat.
Multiply by 3.
Yeah, so if you want to, you can multiply everything by 3. So here I get just an x, 3 x's, that 3 cancels, another x, how are we doing?
Plus 30.
30.
So that's 5x. 5x divided
And
into
now it should be easy.
5x.
Now the hard part's done. X, 4x, 5x plus 30, right?
5x equals 510.
Good, so subtract 30. 5x equals 510. So x is,
Divided by 5. 102.
102. Gotta watch out for the middle 0, yeah.
So the first one is
So now you come back up here and you say, okay, the largest one is 102 degrees. The smallest one is 1/3 of that.
0.33? No.
34 degrees. Just divide that by 3, right? And then the third one is 10 more than the smallest. 44. How do you check yourself? Check yourself. So you gotta, add them all up and they should be 180. Thank God they are.
That's,
So I feel pretty good about that. Now, I'm not saying that they'll all be whole numbers, but if you start getting like 101.8972, that you might have forgotten something in your equation. So you want to make sure that you got everybody in there. That's when you start getting really weird answers.
So is there another way to do it? Because you said let's go ahead and cancel the 3's first.
Oh yeah, so I mean you could just work 2/3 x plus another x would be 5/3 x. You can just work with the fractions for a little while first, or you can just kill them right off the bat.
Okay.
So if you're not so worried about fractions, you don't have to kill them. But if you want to, you always have that option in an equation. Cool. All right. This is so exciting. But I understand as a student, you might not immediately see the value in having a skill like this, being able to piece together a problem. But this happens all the time in real life. You have somebody who did something with a lot of money, and all you see is the final outcome, and you're trying to put a case together against this guy. You got to figure out, well, if you put it in this account, and that account, and this illegal account, how much must have been in each, and then we prove that there was some in the illegal account, because look at how much money you got. Bam! You can't do that shit without algebra. So that's what students don't like, because you have the end answer, you don't know where you started. It's like, dude, just look at your triangle, dude. Just look at the damn thing. No, oh, too bad. All we know is it added the 180 and how the angles interacted, right? We have to be able to work backwards to get to what was going on before. So this is starting to build up that logic in your brain about how to work backwards using algebra. So this specific problem, are you going to have to be able to do this to buy lettuce? I love that. Somebody once said, how's this going to help me buy lettuce? What? How's playing a violin going to help you buy lettuces? You can put anything in there. But this will help you with who knows what. Just being able to do this kind of stuff increases your logic processing, right? I just want to head off that question I knew was coming. Why do you need this stuff? It's a good, there's nothing wrong with that question. It's a great question. All right. 30?
Yes.
Oh, good, okay. Beautiful. That's the next type I wanted to do. Is 31 in the homework? Yeah, right?
Yeah, it's the whole.
All right, I'll do 29. Because I send the homework for you guys. I don't want to do too many of them myself. This is a really good example of one that would frustrate me as a student. So a total of $15,000 is invested in 2 accounts. This should sound familiar maybe. possibly for a few people. One of the accounts earns 12%, the other one earns 10%. Right there, I'm going, why the hell didn't they just put the whole thing to 12? Right? We'll let that go. Maybe it was more risky or something, we'll let it go. Right? If the total interest earned was that, how much was invested in each account? Again, I'm a little worried about the person with all this money and they forgot how much they put in the account. We'll let that go. It's really just a problem that helped me get used to algebra. And it's relatively easy to check, so it's a good thing for an introductory kind of algebra logic class, right? So, the first thing, no numbers, no math, just what are my players? How many players are there?
Two accounts.
Two accounts.
Yeah.
What are the two accounts?
Account 1 and 2. One's me.
They have a,
One and the other.
yeah, one account. We can actually, here we can be a little bit better because they give me a nice name. We have a 12% account
And 10%.
and a 10% account.
Okay.
So those are their names. Right? Now here's where you gotta be careful. How much did they put into the 12% account?
We don't know. We don't know.
We have no idea, so how much did they put in there?
X.
How much was left then to put in the other account?
It's the total.
1,600.
This one.
So for example, if they put 6,000 here, how much must they have put here?
15,000 minus X.
So if they put 6,000 here, how much is left? 9,000. If they put 10,000 here, how much is left? 5,000. What do you keep doing? Whatever I put there, I subtract it from 15,000. Because I've got this big old bag with $15,000 in it, and I go into the bank, and I take out X to put there. So how much is left? The 15,000 minus what I took out to put in there, of course, right? So that shows up all the time when you have a total amount, and then you're splitting it up amongst several things. Like I said, the total trip took 8 hours, and it went this way and then that way. Well, this way would be X, and the other one would be 8 minus X hours. The rest, right? This is where people get those weird answers like you robbed the bank, because you get these negative amounts. How much money did you put in? Negative 8,000. Oh, you robbed the bank. Interesting. Because if you turn this around, isn't that going to change the sign? It's going to be the wrong way. And that's when you start getting those weird negative, like negative length of a board. What material is that? Some black hole type weird ass negative length. That's weird. It's in some other dimension. I don't know what it is. Now, this is a type of problem we haven't hit yet. It's an interest problem, right? So, one account earns 12%, the other one earns 10%. I know the total interest I made. 1,600, right?
Right.
How much interest did I make from each account separately? And then and of course, what am I going to do to get the total interest? How much money did I make from this account,
It's X,
interest-wise?
X times 12%.
Beautiful, right? 12% of X. Because how much, if you put $5,000 in an account, and it's a 5% account, 5% of 5,000 is how much you're going to make in a year, right? So 12% of this money I made here. How much did I make in the 10% account? Careful. How much is in the 10% account?
15,000 X minus.
10% of the amount of money I put in there, right? And how do I get 1,600? I
Multiply.
careful.
Add it.
Add it. I made this much money over there. I wish I could multiply. I made this much money there, that much money there. Together I made $1,600. You guys see that?
Kind of.
If you want to. That's the way to get the equation. A little side note. If you want to, you can do this. This might look familiar to some people. This is, so this is the 12% account and the 10% account. Has anybody ever seen this before?
Yeah.
And here I put X, and here I put 15,000 minus X, right?
Yeah.
That's the principal, that's the amount that I put in there. The rate is 0.12 and 0.10. The interest I multiply across. 0.12x, 0.10 times this much money,
Minus X.
and then I add down, because I want to add them together to get the total interest, right? So that chart's just kind of like an organizational assistant. Just so you just plot things in the right spots, and then you can put together the equation.
Yeah, that's how Nemi taught us last semester.
Sweet, okay, beautiful.